Graphing a linear function is like graphing a linear equation. It can be helpful to change this over to equation language and write this as y equals negative 1/2 x plus 7. And then we can map this to y equals mx plus b to see that we have a slope of negative 1/2 and we have a y-intercept of positive 7. So that tells me that I'm going to pass through the point 0, 7. I'm going to start at the y-intercept. 0, 7 is here on the y-axis. Always start at a known point because the slope is relative. We can draw the slope relative to that point. To use the fact that the slope is negative 1/2, I'm going to think of this as building a staircase. The fact that the slope is negative tells me that as I go from left to right, my steps should be going down. If I were reading it backwards, the steps would go up, but as I'm reading from left to right, the steps should go down. And I have a rise of 1 over a run of 2. So this is my rise, this is my run. From this point, I'm going to step down 1, right 2. You can see as I go from left to right, this makes me go downstairs. Again, down 1, right 2, down 1, right 2. And I continue with this idea until it looks like I have enough points to draw that line. It's great to put arrows on the end of it to indicate that it keeps going. But this is the basic idea. To graph a constant function, we want to take advantage of the fact that we know a constant function has a graph that's a horizontal line. If it's helpful, again, rewrite it in equation language. This is y equals 6. Points that have y coordinate 6. If it's helpful, just generate a few points with y coordinate 6. X can be anything. It could be 0. It could be 2. It could be 7. But note that in all of these ordered pairs, the one thing they all have in common is that their y coordinate is always 6. So if I draw a few of these points, I can see what line they are generating, and then I can go ahead and draw that line. So a constant function always has a line, or always has a graph that is a horizontal line.